All right, so we're going to get started here, and today we're going to talk about factoring polynomials. And everybody on this end can see the screen. And I'm going to go ahead and get the essential question up. So the essential question is coming up. The question is, how is factoring polynomials related to finding the area of a rectangle? So it'll come up in just a second, but for everybody here in person. There we go. So how is factoring polynomials related to finding the area of a rectangle? So, as you guys are finishing writing this down, we know that multiplying polynomials is related to finding the area of a rectangle, right? How is that related? How is multiplying polynomials related to finding the area of a rectangle? If I gave you something like this, remember I asked you to use a generic rectangle to solve this. I know a lot of you guys decided to not do it that way, even though I asked you to do it that way when you did your work. But how is that related? What does the x plus 3 represent if I'm doing a generic rectangle? Okay, so let's go back. Why did I divide that into the parts I did? How come I have two parts? I did two parts on this side. One part, two parts, and then two parts on this side. Why did I do that? Yeah, the x plus 4 has this particular expression has two terms, right? Right here, and this particular expression right here has, how many terms does it have? It's two terms. So I could put x plus 3 here. I could put it on the other side too. It doesn't make a difference. And I could put x plus 4 here, right? And so what does the x plus 3 represent in terms of this rectangle? If these were numbers, what would the numbers represent in the rectangle? The what? The lengths of the sides, right? Right. One represents the length, one represents the width, right? And the part inside would represent the, if I do length times width, the part inside would represent the what? The area. Good job, Chelsea. Okay. Yeah. The x plus 4 would be the length. The x plus 3 would be the width. If I multiply them together, what I get on the inside there in those blank boxes is the area of that, right? So I say x times x, the length times the width of that particular section. I get x squared. If I do the length times the width of this section, I get 3x. If I do the length times the width of this section, I get 4x. And if I get the length times the width here, I get 12. And when I write that out, so it's in its simplest form, I get x squared. And right now, the x's are split up, aren't they? Between here and here, right? And so I need to take those two that are split up and put them back together again. I get 7x in this case, and then plus the 12. So if I'm looking at this expression, where's that x squared always going to be? Every time we did this, where did the x squared part come out? In the what? Okay, and yeah, I didn't ask that very well. In the generic rectangle, where did the x squared always go? You're right, it's always in the front because we always want to go from highest exponent to lowest exponent. So in the generic rectangle, where is the x squared always ending up? Yeah, the top left, right? It's always ending up right in that box. Where's the 7x? In the generic rectangle. I see 4x. Where's the 7x? Because you're combining like terms. Good question. Why did we add the 4 and the 3? Because we're combining like terms. But that's where it is, isn't it? It's the 4 and the 3 together. Okay? There's 3 x's and 4 x's. And all together I would have 7 x's, right? If there was a negative there, then I'd have to subtract them. If one of them was negative and one of them was positive. If they're both negative, I'd have to add them, right? Okay? But I'm going to put the x's together to make it simpler. And then the 12 right here is always going to go down here at the bottom, right? Okay. Now, I'm pointing this pattern out for a reason. And that's why I wanted you guys to work with the excuse me, work with the generic rectangles so you can start to see those patterns. Okay? Because we're going to be using this today. And it's going to go back to this question. So this stuff right here is on the inside of the generic rectangle, right? This stuff is the length and the width. So this is the area. That's the length and the width, right? And I've been giving you the length and the width, and you've been finding the area, basically, right? Okay? So, in other words, I've been giving you the factors, you've been giving me the area, or the actual number answer. All right, so before we get started too much into the actual factoring, there's a little idea here. It says dividing a polynomial by a monomial. So let's think about that for a second. When I did something like this, 3 times x plus 2, and I asked you to simplify that, what did you guys have to do? What did you have to do to simplify that? worry about the division part right now. Just think about the 3 times 300. So there's a few less on this problem. If I do 3 times 5x plus 2, what do I do? Yeah, I had to multiply the 3 by each one of them, right? I did distributive property. And distributive property works not just for multiplication, but it works for division. So what do you suppose you're going to have to do, based on knowing that, what do you suppose you're going to have to do for this problem? Here we had to multiply the 3 times each part. What do you suppose should happen here? Divide what? Yeah, I'm going to divide that, put this part right here, I'm going to divide each part by this. So let's look at that. So that's the first thing I actually did. I'm actually showing the step here. This step, you can, if you get comfortable, you can skip the step, but it's just exactly what Chelsea said. I'm going to say 18x cubed divided by 3x and 15x squared divided by 3x. I have to divide each of the parts that's there. Okay? And then once I've done that, I'm going to get an answer here. So that might be a little note to yourself in this section that's not written here, is that when dividing, don't forget to divide all the parts. Okay? Just like when you multiply. So it's distributive property. Because really what's really happening is you're really saying what's there is just a simplified version of this. So it's distributive property still. Okay? But it's a lot easier to think of it as division than a fraction, isn't it? Right? Okay. So that's just to show you that it really is distributive property. We're going to ignore that and think about it. We're thinking about it. All right. Another quick thing. Greatest common factor. Let's ignore the letters right now. Let's look at the numbers. What would the greatest common factor of 2114 and negative 20 and negative 28 be? What are factors, first of all? Might be a word you need to get the definition for. Let's write that down. Factors are the numbers that you multiply together to get the number you're given. Okay, so what are numbers that multiply together to make 21? Okay, good. What are numbers that multiply together to make 14? 7 and 2. How about 28? 7 and 4. So what's the factor? So when you talk about greatest means it's going to be the biggest one, right? Then common means they have to share it. So of all those numbers that we listed, what's the biggest factor that they share? 7. So the greatest common factor of 2114 and negative 28 happens to be 7. Okay? So when I factor, I'm going to pull that 7 out. The other way you can think about it is, what's the biggest number I can divide into all of those numbers? Is that an easier way to think about it? Okay? What's the biggest number I can divide into all those numbers? And that happens to be 7, doesn't it? Okay? What about, now let's look at the letter A. Notice we're just doing it one part at a time. What's the biggest factor of A that I can pull out of each of those terms? What can I divide? What factor of A can I divide all those by? That's another way to say it. Let's start at the end. The 28b6. What can I divide that by A? Can I divide can I divide that by A? Is there an A there to divide out? No. So the greatest common factor, I wouldn't have any A's to divide out, would I? So I can't pull that out. Okay? What about the B's? What's the biggest factor of B's that we can pull out? Here we have 2 B's, right? B squared, so there's 2. Here there's 5, and here there's 6. So what's the biggest amount we can pull out from each one, or divide that into each one of them? Okay, can I divide this one by 6? Can I pull 6 B's out of this one? No. Can I pull 6 B's out of this one? Let me just do this. I'm thinking about this, and I should have done this in the first place. If I do a generic rectangle here, because this is really like my area, isn't it? Can you guys see that that's kind of like the area when we're doing the polynomials and multiplying? Okay. So I know I can divide all of those by 7, right? And how many of these can I divide into each of those? How many? 2, right. So if I say, can you guys kind of see that there's a division sign there? In a generic rectangle? Can you see the division sign? Isn't it right here? You see that? The division sign? Okay. Actually, that is where the division sign came from. That division sign came from. I'm thinking about it as an area. Okay. So if I'm dividing 7b into 21, a to the 4th b squared, 7 goes into 21 how many times? How many times does 7 go into 21? 3. And if I didn't have this written up here, I'm going to write it way up here so you can see it. So it goes 3 times. And how about the a's? Are they going to change? There's nothing there dividing them, so it'd be a to the 4th. If I go, I forgot the b squared. If I go b squared, and so what number? Basically, you're asking what number here is going to multiply times this. What number here is going to multiply by this number to give me that number? Okay, is this going to work? Is that times this going to give me this? Yeah. I see some people shaking their heads. Okay. How about this one? What number times 7b squared is going to give me this number here? So I need a 2 there, because 7 times 2 makes 14. What about the a's? How many a's do I need? I need all 3 of the a's, don't I? Okay. How about the b's? I need 5. I've already got 2 of them, right? So how many more do I need? I need 3. Good. Excellent. We're going to practice this a whole lot in just a second. So, how about the last one? What number times 7b squared is going to give me the negative 28b to the 6th? Okay, not just 4, but negative 4, right? And how about, I guess there's no a's, so you don't worry about that. How about the b's? How many b's do we need? We've got 2, but we need, okay, yeah, we need 4 because we have to get to 6, right? And so my factors are 7, so I could write this as 7b squared times 3a to the 4th plus 2a to the 3rd, b to the 3rd minus 4b to the 4th. So now it looks like I have a distributive property problem, right? Which is what we saw back here, right? We started with this, which is a distributive property problem. We found that out before because if I take this, it's a double distributive property, right? This times each of these, and this times each of these, okay? And we ended up with the area. And if we took the area and we wanted to find the length of the sides, we'd end up with distributive property. And you can kind of, if I rewrote this, it'd be the 3x times this. Okay? So distributive property gets us to the area. The area can get us to the distributive property by helping us figure out what the lengths of the sides are of the rectangle. Okay? That's helping us, and let's find the pattern here. I want you guys to look at this. There's a pattern that's happening in each of those. It's the same pattern. Okay, so you're basically going to look at the pattern for the first 3 diamonds. We call these the name for these is diamond problems. And then for the 4th diamond, you want to explain how you can find the missing numbers if you know 2 of the numbers. And there's 2 numbers that if you know there's 2 side numbers. Okay? And you figure out the top and bottom number. That's basically what that's saying. And then the 2 side numbers can you figure out the top and bottom number. Yeah, I think you know it. Okay, share with your group for a second. Share with your group. Try with your group, not out loud to everybody else. See if you guys all have the same thing. All right, so what did we get? What did we get? Go ahead. You did a nice job of sharing that. Okay, you multiply the two side numbers to get the top, and you add the two side numbers to get the bottom. So if I made this was an X here, and this was a Y here, what would the top thing be? Based on, we know, because we said we multiply. Actually, I'm going to do it this way. I'm going to type it in because it's faster. We said multiply two side numbers to get the top number and add two side numbers to get the bottom number. All right, so if I had X here and Y here based on what I just said, what would the top be? What am I supposed to do to get the top? I'm supposed to multiply. So this would be X times Y. And what would the bottom be? X plus Y. Yeah. Okay? Now, I'm going to give you a couple problems here. And I'm going to cover up this bottom set and give you a chance to do the top set without thinking about this one. Okay? Now notice they're going to give you always the side numbers, so you have to think about the pattern still and to figure out the other numbers. Okay? So try those. You're getting that third one, that was the first tricky one, right? Here's my second act to remember this outside for I remember trying to do something on this one, but it's better to get some info there. See, a second letter D, go ahead and skip it and come back to it. Okay, most of you got these. So what goes up here? What's up on top? 10. Yeah, 2 times 5 is 10. And multiply to get the top. What goes on the bottom? 7. How about here? What goes on the top? Positive 2 because negative times negative. What goes on the bottom? Yep, because I'm adding the numbers to get the bottom. How about here? What goes on the side? 2 and 4, because 2 times 4 makes 8 and adds together to make 6. Okay, how about here? Because half of 8 makes 4, right? 1/2 times 8 makes 4. So what goes on the bottom here? I multiply to get the top, and what do I do to get the bottom? 8.5, right? I add them together, so I have 8.5. How about the next one? -4 and -3, yeah, because the two negatives make a positive 12 on top, but they'll add together to make 7 on the bottom. Okay? So, same thing, that's just a reminder of our pattern, right? I showed you that before. And let me see if I can get rid of my, there we go. Now you can see those, try those quickly. Now that you kind of have an idea, you can probably zip through those a little bit more quickly. Use these to help us with fast reading. Okay, so what goes there? 5, and the other one is 3. Okay. What do you think? Okay, why not? Right. And it doesn't make a difference which order you're multiplying, right? Okay. What goes up on top? 3, because 3 times 1 is 3. What goes on the bottom? 4, because I am adding, right? How'd you get this number here? 10 divided by 5, because it's this opposite, kind of the opposite direction. So 10 divided by 5 is going to give me the 2 here. And what goes down here? 7. Okay. Kind of the same problem up above, except the 5 and the 2 are reversed, isn't it? So that kind of answers the question. It doesn't make a difference which order they're in, right? Okay. How about this one? What's this one going to be? It's 1/2 times 1/3. And we multiply. 1/6. Good. The adding is the tough part there. 1/2 is the same as 3/6. I'm going to give you a hint. 1/2 is the same as 3/6. Yep, because 1/3 is 2/6, isn't it? Okay. So you get the hang of that, right? And the problems that are like this one right here, or like this one right here, are actually going to help us today. Where I'm giving you the top and the bottom number, but you have to figure out the two sides. They're going to help us today. I've kind of reviewed this idea that we're going to multiply everything. So let's just quickly do this one. Can you guys quickly just use the generic rectangle, quickly do this? I don't want to spend a whole lot of time on talking a whole lot about this, except we do need the problem, and we do need it worked out. Notice I put the subtraction sign with the 5, so I know it's a -5. So remember that. -5. So most of you did this, and then you got this, then you did this, and then you got this. Okay? Now, remember our diamond problem, we said that if we take the two numbers and add them together, we get the bottom part, right? Okay. Oops, I'm sorry, thank you. My mistake, that should be a negative 10. I was hoping people do that too. So, thank you. I'm glad you guys are awake. All right. So, let's look at this. How does the diamond problem, we're going to find out how the diamond problem relates to this. Okay, ready? Now I'm going to write this out. Yep. So how does the diamond problem relate to our generic rectangle and our solution? And I'm just going to show you something I noticed that somebody did. And I think this is a really astute observation on that person's part. They said they did this. They did this on their paper. Why did they do that? Why did they do this? Draw a circle around the negative 10x and the 3x. Negative 10x plus 3x. Okay. So they put that around and put their two things together, right? Okay, so what do they do? The negative 10x and 3x, and what do they do with those two things? Negative 7x, what do they do? I added them. First, they look at your diamond problem. You notice. Negative 10 and 3. Where did the negative 10 and 3 come from? From the diamond problem. There's actually from the generic rectangle, right? Right? Okay. Where did the negative 7 come from? I add the negative 10x and the 3x together to get negative 7x, right? Okay. Now where does this come from? I didn't actually. There's a good spot. You can choose it up in the left. It's not the biggest mistake. Because negative 15 is not the negative 30. Yeah. I multiplied the 2 times the negative 15 and got the negative 30. So I multiply it. So let's go over that one more time. The negative 10 is here, right? The 3x is this right here. When I add these two together, I get the negative 7 right here. That goes right there, right? And then you guys notice that the negative 10x times the 3x made the negative 30, but that was a bad choice on my part in terms of numbers, because that's not where it is. But then you notice that if I go this way, the 2 times the negative 15 does make negative 30, and that is exactly what it is. This is that part right there. And you can see the negative 15 right here, right? That matches right up here. And the 2 right here matches up here. So that 2 times the negative 15 goes right there, doesn't it? And the negative 7 goes right there. So if I gave you this to start with, I can use this to help me figure out what goes on the outside and how to split up the x's here on the inside. So if I gave you the top and the bottom part, which I did right here, didn't I? There's the top, there's the bottom. You see that pattern? Pretty cool, huh? Okay, so we've kind of already talked about it. What happens if I give you 2x squared minus 7x minus 15, which is what we had, right? And ask you to find the factors. So the first thing you can do, first thing we know to do is it's going to go into our generic rectangle, because we know that's the inside of the generic rectangle, right? So if I draw that, no, I don't like that color for this. That's not what I want. And so if I draw that, my generic rectangle, based on what I have, what do I know? What do I know that I put here? What's going to go there from what I gave you? Which part of that problem goes in that top upper left-hand corner? 2x squared. Yes, the x squareds go there, don't they? What about here? What goes there? The negative 15. Okay, now, because of the last problem, we kind of know what goes in these two boxes, but if we didn't have the last problem, what do we have to know? We have to know that this has to be split between those two boxes somehow, don't we? Right? So the first thing I'm going to do is I'm going to make my diamond problem. What's going to go on the top? How did I get the top number from that? I said this number times that number, didn't I? Right? We agreed on that? So I'm going to put negative 30. What goes on the bottom? The negative 7, because that's the number that when I add the two boxes, that's the number I get, right? So then you can ask yourself, then we can figure out what goes on the two sides, can't we? What's going to go on the two sides? What two numbers multiply together to make negative 30 and add together to make negative 7? Is it negative 7 or positive 7? Did I make a mistake? No, it's negative. Okay. So what are the two numbers that go on the sides? Negative 10 and 3. So once I figured that out, I just take those numbers and I put them over here. I'm going to put negative 10x because it's the x's I'm finding, right? I'm going to put 3x. And then I'm going to do some factoring. Remember when we did our greatest common factor? What can I divide both of these numbers by? What's the biggest amount I can divide both those two numbers by? Okay, I can do 2. There's somebody say 2. The 2x squared and the 10x. Somebody said 2. Is there anything else? How about it? How about the x part of it? They need an x, okay? So if that's 2x, what goes up here? X, good. What would go up here? Negative 5, okay? So what number would have to go here then? Let's look at our, we're trying to find the area of this box right here, right? Yeah, because x times 3 is going to give me, right? Gives me that. And negative 5 times 3 would give me negative 15. These also have a 3 in common, don't they? Okay? So I can factor that out, and it's a positive 3. And so I just figured out the length and the width of that rectangle. Pretty cool, huh? Using our patterns that we find to do that. So math isn't so magical after all, right? There's lots of patterns that we can find to make it work for us. So if I'm asking you to factor, I just found the factors. 2x plus 3 is one factor, and x minus 5 is another factor. Okay? You guys ready to try number 2 on your own? Okay, let's try it. Let's see what we've got here. Let's try this one. Okay, what's the first thing we want to do? First thing we did was we built the generic rectangle, right? So let's build that generic rectangle. And then the next thing after we built that, what did we do? Build in what we could, right? So where does the x squared go? Okay, we're going to fill in the rectangle. So where does the x squared go in the rectangle? So put it in there. Where does that's 3x. That gets split, right? We can't do anything with that yet. Where's the rest of the negative 18 go? The bottom right side. Now what is we do? Make sure it's negative in there. What did we do to figure out how the 3x is split? So we know that the x squared goes here. The negative 18 goes here. What did we do to figure out how to split the 3x? What did we do? In other words, what's our next step? I have to make the diamond problem, right? What goes on the top? How do we get the top number? This times, what number's here? 1, okay. So what number goes on the top? In this case, it's just the same as the end, but that's just because the first one is a 1. What goes on the bottom? Not x, not the x, it's the, what number goes on the bottom? No, you already got 3. Good. Oops. So what goes on the two sides? Now you guys have to work. Your brains have to work a little bit. So 2 numbers multiplied together to make negative 18 and add together to make positive 3. Figure out where those numbers go. Most of you did pretty quickly this. So where do those two numbers go? Right there in those empty spots, right, with the X's on them. So how do I figure out what goes on the outside? How do I figure out the length and the width? Because I have the area, that's what I gave you, right? How do I figure out the length and the width? What's the question I'm going to ask myself? So what does the x squared, what can I divide into the x squared and the 6? What did the x squared and the 6x have in common? 7x, good, so that's what's going to go here. So what would go here? What would go here? Plus, okay, plus what? Plus 6, because 6 times x makes 6x. Then what would go down here? -3. So when I'm done, I just write x plus 6 and x minus 3. And I've just factored that item. Okay? All right, so, and I do want you to use this when you're doing some of your work, okay? You're going to practice this. You'll see another method after that, but I want you to practice some of your work for the next few days. Oh, what happens on this one? Just a quick question. How many x's are there? 0. Yeah, so I can think of this as 16. If you see problems like this, 16x squared plus 0x minus 1. Okay? If there's a part that's not there, it's always 0. And just as a quick summary on this, first thing we kind of did was look at the ABC part of the variables. That's the numbers with the variables. A is with the x squared, B is with the x, and C is the constant. You built first of all, we built the generic rectangle, right, and filled in where we needed. Then we built the diamond problem to help us break down the two parts. Then we put that information back into the generic rectangle. And then we factored each row and column, right? And then we wrote out the factors. Okay? And I forgot to put in here, I'm going to add this build generic rectangle. And so we filled it in as much as we possibly could. And then we went to the breakdown, right? And I even leave it that way because you know that means generic rectangle, right? Okay. We're going to get a lot of practice with that. We're going to get lots of practice with that over the next week, actually. Okay? So, we'll come forward with that. Make sure if you didn't sign in, so that you may take every day. And if you sign in, before you leave, make sure you do a quick summary. Okay, and so we're going to stop the recording.